Greetings everybody! Today we're going to run a very simple experiment that will try to show the discovery of electricity and all its properties. To run the experiment we need just two simple plastic glass. Those glass are free to move and free to fall to the ground as we expect them to do. Now I wrap the glass like that. And as you can see, the glass don't fall anymore, but there's also another properties. I take the first glass, and I take the second one. Let's see what happens if I put the second one close to the first one. I try to get as close to the camera as I can. Seems like it's pushing. Let's see if I charge it even more. Take this one. You see? If I release. Okay, so let's see what happened here. Before rubbing glass, there was only gravity. After rubbing glass, there was a new force. We call this force electric force. Why we call it electric? Because the first people to report such an event were the ancient Greeks. They found that by rubbing a rod of amber, this rod of amber was capable of attracting pieces of hair, dust or stuff like that, much the same way my vest was attracting the glove. But amber in Greek is called electron. So here the source of the origin of the name. Electricity comes from electron. Second concept, electric charge. We have to go back to the 18th century when they started investigating this force. And back then they tried to describe the force much the same way they managed to describe gravity. Theory that describes gravity says that the source of gravity is the mass of their bodies. So my body has a mass, it's a source of gravity. My body has a mass, it feels gravity. This glove has a mass, it's a source of gravity and it feels gravity. But there's also the Earth. The Earth is a much bigger mass, it's a source of gravity and it feels gravity. So when we are dealing just with gravity, the force of the Earth is way much bigger than my force. That's why you see the glass falling and everything we see falls to the ground, because the attraction of the Earth is way much bigger than any other gravitational attraction we have on Earth. So in order to push the similarity, the science community said, let's assume that some piece of materials may or may not have a new property that we call charge, electric charge. Now we know why we call it electric. And this charge gives a new property. The property will generate a new force, which is called, of course, electric force. So when you get the charge, only when you get the charge, there is this additional force, like what happened after rubbing the glass. So I had the charge, the glove had the charge, and there was a new force, electric charge, that was much stronger than gravity, and the glove wouldn't fall. Third concept, positive and negative. Positive and negative come from the fact that we saw that the two gloves putting together, they didn't attract each other like we would expect, but they were repelling each other. So how did they describe this phenomenon? By assuming that there are two kinds of charges, a positive and a negative charge, and assuming that charges of the same type repel each other, the charges of opposite type attract each other. This actually comes in very handy, because before rubbing the glass there was no charge at all. After rubbing it, if I got some positive, the glove got the same negative, so the total was still zero, or vice versa. So since the gloves are identical, of course they got the same charge, so they were attracted to my body because opposite charge, but they were repelling each other because of equal charge. So what's left to do now is just to conventionally decide which one is positive, which one is negative. This task was performed by a guy named Benjamin Franklin again in the 18th century, and this was performed once and for all, and that's the rest is history, because now, thanks to this convention, we can say that the proton is positive and the electron is negative. That's it for the story. I apologize for my terrible English. I hope the video turned out clear and understandable. See you next time. Bye-bye.